In this video, we'll introduce what the idea of a matrix is in mathematics, the plural of which is matrices. So we'll, in this video, just really talk about kind of what they are, how to classify them, what elements are. Really, it's just mostly an exercise in vocabulary and basic information about matrices. There's a lot of things you can use them for in mathematics, and we'll talk about those in later videos. So let's talk about what a matrix is. So a matrix is a way of arranging data, is usually kind of the typical example that's given. And the idea is basically it's just going to look like a string of numbers. And it'll be arranged in a manner of data set. Now it could be like, okay, say we're looking at shoe size here. That'd be each row or each column potentially. It could be a different thing. So like say this is shoe size here, and then like this could be some way of quantifying color, like eye color. And then the last one could be some other thing we can measure, hair length, for instance. And then we would have each individual has these different things. So person A, B, and C, for example. And it's just a way of simplifying things and really condensing data into a thing, but you have to understand what each row, what each column means. So that's a typical example. Now sometimes, especially in mathematics, we'll talk about, okay, what can we do with just the numbers? How can we use them? What can we do with them? And that's what we'll kind of talk about here today. So before we get too crazy, let's talk about how to classify matrices. And we would do this by classifying it by its rows and its columns. And we'll talk about why that's important in a second. So if we're given a matrix, what we'll talk about first is we will classify it rows by columns. So like for example, if we were talking about a 2 by 4 matrix, and that's how we'd write it with a 2x4, where x means the word by. So that would mean that we're going to have two rows. So we'll have two rows if we look at our matrix. So let's say we have one where, all right, we've got 1 and we've got 7 for the first column. And then we'll have 4 columns. Rows come first, columns come second. So my 2 by 4 matrix, as an example, would look something like this. This could be an example of a 2 by 4 matrix. And I'm just making it up on the spot just to give an example. So we would classify this. This would be very different than a 4 by 2 matrix. It would look, instead, we'd have 4 rows. So it would be like 1, 2, 7, 8, 9, 12, 18, and let's say 32. There's a difference between these two matrices. They could have very drastically different meanings. So it's worth kind of this whole idea of understanding, okay, when we're talking about a 2 by 4 matrix, is a very, very specific matrix that we're talking about. And then we can identify particular elements in these. And that's what all these individual numbers are called, elements. And we can identify them by their row and their column. So like for instance, this 6 right here, it's in the second row, third column. And that can be kind of useful if we're trying to isolate one particular piece in this matrix, one particular element. For whatever reason, we can identify it by its position in the matrix. And a lot of this it's fairly intuitive. We're just assigning vocabulary to it right now. So there's dimensions, how to classify, what the rows and columns mean, and elements, rows, all that stuff. So let's talk about adding and subtracting when it comes to a matrix. In order to add or subtract a matrix, they both have to be the exact same size. Meaning, like in our last example, I can't add a 2 by 4 matrix to a 4 by 2 matrix. I can only add matrices or subtract matrices that are the same size. So let's say, just for the sake of simplicity, we have a 2 by 2 matrix. So let's say 1, 2, 3, 4, and then I'm going to do the same thing where I have 5, 7, 2, and 9. I can only add these because they're both 2 by 2. And then how I would do that is I would add up each corresponding element. So I'm going to correspond the first row, first column elements, and I will just add those. So it will result in 6, then I would move on to the next element. I'm going to combine the 2 and the 7. They are in the first row, second column. 2 plus 7 makes 9. Likewise, I will do the same thing with the 3 and this 2. I'll move on to the next row. So 5, and then our last one will be 4 plus 9, which would make 13. So we just very much add where we have corresponding parts. So like, for instance, if I tried to say, all right, let's add a 2 by 3 and a 2 by 2, or even a 3 by 2. Let's do that. I cannot do this. It is not possible. Because, I mean, even if we think about it, like, okay, sure, maybe we could do these two, maybe we could do these two, and then what? What do I do with the 9? There's the question. Like, how does it make sense in that regard? So they must be the same size, and then we can add, and we can even subtract, and it would be the same sort of thing. Instead of adding, we'd be subtracting. So we can add matrices, we can subtract matrices, but they have to be the same size in order to do so. Now, one last thing we can do with matrices is we can do what's called scaling, which is essentially I'm multiplying, but I'm only multiplying by a single number. So like, for instance, say I have, for the sake of simplicity, let's say it's a 2 by 2 matrix. I can multiply everything by a single number. And in this case, that single number would be 2. And I would do this similar to the addition and the multiplication. Basically, I'm going to distribute in this 2 to every single number in here. So I'm going to double everything. Or I'm going to scale it up. If we think about scale factors in like geometry, it's the same kind of idea. And that's something we can do with a matrix. And it might not make sense, those last two, as to why they would be handy in, like, say, a data situation, but this is something that we can do with matrices. It's something that's possible to do with matrices. So that about wraps up like the introduction for a matrix. We will use these to ultimately solve systems of equations, among other things, but that should be enough to at least get you started, or at least kind of introduce the idea of what a matrix is.